Bristol Community College, Mathematics with Dan Avedikian, Math 131, Elements of College Mathematics, Section 3.1, Problem 10. This is Section 3.1, Problem 10. It says, graph the feasible region for the system of linear inequalities and determine if it is bounded or unbounded. So when they say system, they just mean that you have more than one at a time. And we have two. X plus 4y is greater than or equal to 7, and x plus 2y is less than or equal to 5. So what I'm going to do is first focus just on the first one with the 7 at the end and graph that, and then when I'm done, then I'm going to graph the other one. I'm not going to try and deal with both at the same time. So the one with the 7, I'm going to start with step 1 of my 4-step process and pretend that it's x plus 4y equals 7 and find 2 points with x and y values that make this true. So first, I'm going to let x equals 0 and solve for y. So if x is 0, I have 4y equals 7. So I could divide out the 4 and I have 7/4. I have a fraction, but that's not as bad as it seems. Just write 7/4. And 8/4 is 2, so it's almost 2, a little less than 2. And now for a second point, I'm going to let y equals 0. I'm going to get a whole number this time. If y is 0, that 4 times y becomes 4 times 0, and I'm pretending it's an equals. I just have x equals 7. So 7, 0 is a second point with x and y values that makes my linear inequality true if I pretend it's an equation. So yeah, I'm not even going to get into the one with the 5 yet. Let's graph the top one with the 7. So now I'm going to go on to step 2 and plot the 2 points that I found in step 1 on my graph. And I have my graph ready to go here. So one of them is over 0 up almost 2. Again, 7/4 is almost 2. If I had 8/4, that'd be 2. So it's going to be a little under the 2, and you can just go by eye. So over 0 up almost 2. So here's my 2. I'm going to just by eye go a little under, and that's fine. And then the other point that made this true from step 1 is 7, 0. So I go over 7 up 0, so right there. And that's step 2, plot the 2 points from step 1 on the graph, so I plotted them. And now step 3, connect the 2 points from step 2 with a straight line. So I'll use my ruler. I'm going to put my straight line. I'm going to use a solid line because the inequality symbol has the or equal to in it, like that. So there's my straight line. Again, it's solid because my inequality symbol has this or equal to. Now, finally, I have to do step 4, and that is determine whether I shade below the line I just drew or above. So now, to determine which half you shade is choose a test point that's not on the line. Use 0, 0 if you can. 0, 0 is not on the line. So I'll plug in the coordinates of my test point, 0 for x, 0 for y, and see if the result's true or false. So 0 for x, 0 for y, I have the statement 0 is greater than 7. Well, that's not true. 0 is not greater than 7. So my test point was on the underneath side. The result I got was false. So that means the underneath side is the blank side. Therefore, the part up above is shaded. So since I have another line to draw, I'm not going to shade too much, like that. Now that I'm done with the first linear inequality, now I'm going to graph the second one on the same graph and see what type of result I get. So I'm going to use a different color to make it a little more clear. And I'm going to start with step 1, pretend that the inequality I have is an equation, and find 2 points that make it true if I pretend it's x plus 2y equals 5. So first, let me 0 the x. If x is 0, I would have the equation 2y equals 5. Again, I'm pretending it's equals. So to solve for y, divide out the 2, and I'd have 5 halves. Again, I have a fraction. That's OK. 5 halves is 2.5. And again, you can estimate that by eye. Don't let the fraction bother you. And now for a second point, I'll let the y be 0. So where I have 2 times y, it becomes 2 times 0. That's going to go away. And I solve x equals 5. Well, that's very easy. Just x equals 5. So now, for the second linear inequality of the problem, I have 2 points that make it true if I pretend it's an equation. One of them is x is 0, y is 5/2, or 2.5. And the second point is x is 5, y is 0. So the first one, I would go over 0 up 2.5. So over 0 up 2.5. So here's over 0 up 2.5, right between the 2 and the 3, 2.5. So it's close to the other one, but not exactly in the same spot. And the other one is over 5 up 0. So here's over 5 up 0. So now I have my 2 points. That's step 2 of the 4-step process. Plot your 2 points from step 1 on the graph. Step 3, connect the 2 points that you just plotted with a straight line. I'm going to use a solid line because I have the or equal to in the linear inequality. So let me take my ruler. Let's see. And I will connect them with a straight line that's solid. Like that. So they do cross here. Now I have to decide whether I shade above the red line or below it. So what I want to do is find the test point that's not on the line. I'm going to use 0, 0 since it's not on the line. That's my favorite test point. And put in the x and y coordinates of my test point into the linear inequality that I have to graph and see if the result's true or false. So for 0, 0, x is 0, y is 0, the whole left side of the inequality I'm graphing zeros out. And I'm left with the statement 0 is less than 5. Well, that is true. 0 is less than 5. So now my test point was on the underneath side. The result I got was true, so everything underneath is shaded. So I'm going to shade underneath. Now, the feasible region is the area that satisfies both inequalities at the same time. So the area underneath the red line and above the blue line is this triangle I'm getting right here. So my feasible region is the area trapped between the red line and the blue line to the left of the point where they intersect. So not to the right, to the left of the point where they intersect. Everything trapped in that wedge satisfies both linear inequalities in the system at once. And the end of the question is this feasible region bounded or unbounded? Bounded meaning completely contained, or unbounded means it goes forever. This would go forever off to the left. So this is an unbounded feasible region.